to kick off, so I'm going to talk about open innovation in mining, and this is basically an updated version of a talk I gave at an IMARC conference in 2015. Just as an aside, the IMARC was a conference held every year in Melbourne, and it was underwritten by the Victorian government as a means of trying to make it the preeminent mining conference in Australia. There's a conference called PDAC in Canada that's famous, and there's one in Denver every year in the US. And they wanted to say, you know, all we've got in Australia is what's called the Diggers and Dealers Conference.
Yeah, I know about that one, yes.
And so they thought, let's make it a major event. But the Victorian government only ever treated it as an event to be run to bring people to the conference centre and also bring people to Melbourne around November at the time of either the Spring Carnival and or the Formula One racing. So part of the major event strategy. Well, for those that remember, the last face-to-face one I attended was 2019, and there was a big Extinction Rebellion demonstration. And I don't know this for sure, but I assume the Victorian government has decided, I don't think they want this again this year, in an election year in November. And in addition, because they were really only underwriting it as a money-making exercise to bring punters to the conference centre, then they were actually losing money because of the cost of the policing. Horses and others was way beyond whatever profit they were making. So guess what? It's now moved to Sydney.
And yet another weird place to have a mining conference. I mean, what would they mine? Coal in New South Wales and coal in Victoria. There's not much else, is there?
Well, there is an underground in Sydney.
Well, you know why the ASX is based in Melbourne, Peter?
Why?
No. Because Melbourne was the commerce centre of Australia during the gold boom.
Yeah, I knew that.
And so the first companies that were being created, like Broken Hill Proprietary Company, were all listed out of Melbourne, off the ASX. And so Melbourne became the centre of mining for Australia. And that's why so many head offices were and still are actually based out of Melbourne. And so there's a heritage aspect of that. Okay. Anyhow, so I was going to give this talk, an updated version of this talk last year, but the conference got delayed because of COVID, the latest round of COVID last year. They decided to postpone it till 2022, early 2022, and then they cancelled it and then gave it off to Sydney to run it this year. I don't think it'll be that successful in Sydney for the very reason you're saying, Peter, neither Melbourne or, at least Melbourne does still have some head offices like BHP's head office. In fact, you notice that BHP is what's the word for it? They're closing their UK, you know, the BHP PLC. The dual listing, that's it. The dual listing. So Melbourne is going to be the only head office for BHP ongoing. Oh. Rio still has a head office in Melbourne and in London because they're still dual listed. But anyhow, so I was going to give this talk last year and was going to update it, but I'm not going to bother going to Sydney. I just don't think it's going to be that successful, and looking at the program doesn't look that impressive. Anyhow, so open innovation in mining. I want to give lessons from past experiments in open innovation, look at some of the challenges in what you'd say is crossing the chasm from a pilot project to commercial success, and opportunities from new emerging models for open innovation. And to give you some of the examples of those open innovation. So let's move on. So going to give an introduction, drivers for change, talk about what open innovation is all about, and then just go through these examples basically.
And what's with the young photo?
Yeah, I need to update that, don't I? Just so I'm an old, there's graying around the edges. Yeah, that's actually from a CSC photo time. Anyhow, the
Colin from a better day.
yeah, and taken by a professional photographer. All the ones taken since have been selfies that look pretty ordinary. Anyhow, so The objective of the talk is to demonstrate how open innovation in mining has moved from a crawl to a sprint that really kicked off in 2015, the very year I was presenting this. It was, part of it was, well, why has it been so slow? Why is the mining industry so slow in this whole move to open innovation? And then it just really took off. Not quite sure why, but it was really just an example of a couple of people had a go at it and really got some interest happening. I was really presenting this as a dual presentation from Indago Partners and for the Pearcey Foundation. We've talked about the Pearcey Foundation before, but I thought I'd go through that again, particularly after Ian's excellent history lesson on the history of computing to revise that. So we had CIRAC that was really called CIRAC Mark, CSIR, I can't remember, Mark 1 it was originally called. It got renamed to CIRAC when CSIRO was created as an organisation. It had a different name before. Anyhow, to cut a long story short, it got working in November 1949, which makes it the fourth stored program computer in the world, where basically, and it's the only intact version of that first generation stored program computer that's still in existence. All the others got scrapped, partly because almost every one of those other ones went on to a version 2 and they, scrapped their version 1 as obsolete. Whereas we'd done such a good job in making version 1, they just kept the same thing going. And as we've discussed before, some of you that have, like Peter, anyhow, so that'll come up. But just to describe CIRAC a bit more, it actually had a paper tape input and output, a whole 2,000 bytes of memory. The programs were stored on this 5-track paper tape system, and with machines to punch the tape and read the tape. And these particular tapes I'm showing there actually are ones that are actually output of a calculation by John Spencer of CSIRO in the early 1960s for solar positioning and measurement and estimation of solar radiation on building surfaces. And it led to a publication of tables for all Australian capital cities. And it's still used today for solar panel calculations.
Wow.
So it was used for more than radio astronomy and other, or not radar uses, what it was, what Pearcey's area of expertise was, but it got used for all sorts of things. It was.
I'm quite interested
That's
in the
amazing.
paper tape down the bottom, Cole. Freedom Business Systems. Do you know that was one of the first companies I applied to actually get into computing? And it was probably only 3 years. I didn't get the job. It was only 3 years after that they went out of business. So that was a good thing. But they were very big on this paper tape stuff.
Right.
I mean, they were sort of a bit up from accounting machines. I guess that was about what they were.
If you think of how many early programs that are stored on other medium that has long since degraded, it's interesting that those programs, they still actually work, that were stored on paper tape, of course, because it just holds in tape and paper will last pretty much forever. And they have actually built emulators. You can actually run the CIRAC programs in a PC emulation mode.
Okay.
Sorry?
Yep, good, mate. It's fine. Continue.
Yeah. It was also the first portable computer because it moved in 1955. It moved from Sydney to Melbourne, and there's the stopover in Benalla. And then it moved again from Caulfield to Carlton in 1992. So as Peter, did you ever see it in the Caulfield Museum, Peter?
Yes.
Yeah, so Trevor Pearcey set up a museum in Caulfield Institute, and that's why when Melbourne University had finished with it in 1992, sorry, I can't remember. Melbourne University, I think, finished with it in about 1960. So from 1955 to 1960, it was used by Melbourne University. And the interesting part of that is that it was the first computer in Australia that was made available to undergraduate students. By the time 1960 came along, or 55 came along, there were other computers in Australian research institutions for research purposes. But this was the first one that said, well, we'll have CSIROC and we'll start teaching students. So it was really the birth of computer science as a discipline in Australia was because of CSIROC. Anyhow, getting back to the mining part.
Just a minute, sorry. Lucky it didn't rain when they transported that computer.
Oh, look at all the tarp. They had plenty of tarp. Don't worry about that.
Were they waterproof?
Well, of course. That's what.
Okay.
I've yet to see a waterproof tarp.
Same here.
It's the gaps between. It's not one tarp, right? You can see it being unfurled there, but that's the problem. It's got the overlapping tarps is where you're going to get into trouble.
Hey guys, it was done in 1955. It was done properly, all right?
Yeah. Well, yeah.
But anyhow, but that's an interesting point, the fact that it was portable in the sense no other computer of that early phase was ever moved. Some were moved from the point of development to the customer once. This one was moved from Sydney to Melbourne and got working again, and then worked for many more years after it. So it's quite a there was
quite a feat.
Just as an aside, we had the Pearcey oration last week. The oration was given by the relevant minister, Ed Husak, federal minister. I think the first time maybe a federal minister has given the Pearcey oration. He gave an excellent talk, and when it's put up on the Pearcey site, I'll share with you the link to it. It's well worth looking at, because I think we've finally got a federal minister that actually understands innovation and the digital.
So he was a better after-dinner speaker than Trevor ever was?
Probably, yes. Yes. He's a politician. Of course, he can speak.
Oh dear!
He knows how to, and he gave a really good speech. Anyhow,
Trevor was the worst after-dinner speaker I've ever had in my misfortune to.
Trevor who?
Listen
Trevor
to.
Pearcey, yes. Anyhow, okay, and we got that last time I raised it, and Peter had him as a lecturer, so it was even worse for him. Anyhow, okay, what are the trends driving change in mining? Why innovation needs to be happening? We've got these value drivers and business challenges are both combining to create a need. And I'll go into a bit more detail, but just to pick out a couple of those drivers, well, you've got the main driver really is just the commodity price and the boom and bust we've gone, and that's an up-to-date version. And by the way, Peter, your view of we could be into a dangerous time, I don't like the look of this recent drop we've had. Actually, in the last month, I started looking at multiple commodities to see indeed it was across multiple commodities, except for gold and of course oil and gas is holding up because of the Ukraine situation. But and gold always holds up in times of crisis. So, but other metals, whether it be iron, all these metals in this index, copper, aluminium, iron ore, tin, nickel, zinc, lead and uranium, this is a combined measure, which gives you a sort of a smooth version of what the boom and bust really is of each commodity. So you can see here's the 90s, living through the 90s, we had this boom and bust cycle that we called, but because we're only looking at that view of the world, we thought that was a big roller coaster ride in the 90s and all going south. Then the China boom came, and up to the GFC was like bursting the bubble, and it dropped and then came back very strongly. Of course, the mining industry came back stronger than any other industry after the GFC. And then, around 2013 or so, it went down into another long downturn and a lot of cost cutting before returning in around 2016. It started to come back, and it's been back stronger. So this recent peak is higher than any previous peak. So we're back into a mining boom, if not, maybe it's going to crash like, I think it's going to be one of these things, actually. If it does crash further, it'll be a big speed bump. Yeah. But anyhow, it's the big driver in the industry.
Do you think it will, Colin? Do you think it'll be another crash similar to what happened in as part of the GFC?
Well, yeah, let's not get into economics, but, personally, I think one of the things is that during the pandemic, when every country in the world got into printing money, I remember at the time thinking, yeah, well, they used to complain that government shouldn't print money because it's going to increase inflation. But everyone was printing money. So the fact that we've now got inflation doesn't surprise me at all. That was absolutely predicted by economists. Yeah. If you do this, then this will happen. Well, they did that. They printed money like it was going out of style, every single country. you know, we're now seeing the inflationary effects. And honestly, I was thinking too that it is a bit ominous that when you have high inflation and a unrelated spike in oil prices, it just reminds me of the 1970s, the early 70s. You know, basically the recession that killed off the Whitlam government was at the time of the OPEC, and we had really extreme inflation and interest rates at that time, but we also had the OPEC oil price rise. So yeah, that sort of worries me, that coincidence. But anyhow, nevertheless, on a long-term basis, from a mining perspective, that trend, going back to that trend, I think we are going to, you know, there's no reason that those metals are going to go down. You know, the demand is increasing on them all. Yep. It's not because of oversupply in this particular. That's what tends to happen for a while. You get a bit of. I think that's what happened here during these booms. We had so much new projects and bringing new metal to market that's what I think was the cause of that down, was oversupply. You know, the classic. What do you call it in supply chain? Is it the whiplash effect in supply chain management, when you got this delay between the demand and then your ability to service that demand by opening new mines, you get that. That's a natural effect. I don't see that happening this time. You don't have this wealth of lots of projects that were happening in the late 2000s, early 2010 sort of period. Anyhow, but it's not the only value driver. You've got cost competitiveness has always been a driver in the mining industry as to how do you get competition. The resource base, who's got the best resources, often wins the game. The capital availability to do these major projects, and sustainability, and I've put it there, dams, caves and climate change is really what sustainability is. And that's probably become the biggest recent driver in actual fact. Because of dam failures, blowing up caves, and of course towards net zero. And business challenges currently, we're mining deeper and lower grades, supply chain infrastructure constraints, specialist labour and equipment shortages, and increased regulation and country risk are all adding to make it really difficult to do mining these days. So you end up with these strategic imperatives. How are they trying to respond to that? And they're trying to develop and produce better and faster, reduce operating costs, increase the viability of future projects, finding new ore bodies, reserves projects, reducing capital costs, and reduce health and safety risks. Well, interestingly, that little dark green bar is basically from this particular survey that showed how important they were asking CEOs and other leaders in the industry what they thought were the main drivers, the imperatives for the industry. And that's how they voted with them then. I would say these days, if you and these guys have been running this state of play thing, but they haven't been asking. Unfortunately, they didn't ask the same set of questions over and over again, so we can see the trend. They keep changing the bloody thing. But anyhow, if you were to ask the same questions, I reckon that would be completely inverted. You know, this would be number one, number two, you know. It just goes to show you how the change in the market. So going back to that point, you know, that view is from that period when it was in a decline. So, of course, cost cutting, they still wanted to produce better and faster, but they had reduced operating costs is right up there. Now, they're not so worried about that. They're very worried about the availability of capital and these risks around it. And we're not finding the new ore bodies we need. And then that really implies, you know, those imperatives to me implied we need step change. We can't just have incremental innovation. We've got to somehow get the step change either with new business models and or next generation technologies, preferably both. And so meanwhile, back at the rest of the economy, you've got digital technologies as a disruptive enabler right across the board for so many industries, where you got cloud and the back end, big data and everything goes with that. We got mobility systems of as social networking and AI and all stitched together by improved and advanced communications. These things are disrupting all industries, as we know. And if you want to look at how that plays out in mining, those particular technology disruptions are giving rise to key technology enablers. And again, I've looked at an external source for these, and in 2014 there was a really good article on what were the 10 technologies that will rock the mining world, and again in decreasing order of popularity from this survey of 70 mining industry leaders, and it was a pretty good list at the time. Big data, advanced analytics, top of the list. Connectivity, intelligent integration and communications, sensors and mobile devices, Internet of Things, robotics and equipment automation, integrated planning optimization, digital mine, visualization, simulation. Again, if I was to look at that now and say, if that survey was run again, I reckon it'd be inverted. I think this would be on the top of the list, followed by that, followed by that. Either way, I think all of those items are important. And if you now combine, what happens with innovation is when you get these business imperatives and at the same time these key technology enablers, so you get the push and the pull working together, is where you get these real opportunities for innovation. Now, from a mining industry perspective, it really has been an industry that hasn't innovated very much. And this, I like this particular slide from Clario Partners, where they just show it graphically. You know, just think of what the airline or aircraft aerospace has gone from the early parts of the 19th century to now, and then the telephone. Just as an aside on the telephone, I only read this quite recently that, of course, Alexander Graham Bell gets all the credit for the telephone, but he came to visit Henry Sutton in Ballarat and was amazed to see that this inventor in Ballarat had worked out how to get the microphone and the earpiece in one unit. Remember those early telephones where you'd have a box on the wall and this thing on a wire to put to your ear?
On a candlestick,
That was what the first Alexander Graham Bell telephones were like. And he comes to get Ballarat and said, holy shit, you've worked out how to get this working together, because there was some trick to it that escapes me. And of course, he ferreted that away and went and stole it and improved on that. So meanwhile, we did nothing about telephony in Australia. And then you look at the motor car, what car manufacturing and the cars themselves, how much they've changed, particularly as we go into electric cars and autonomous cars. Meanwhile, mining, you look at mining in the early 1900s, that what it looked like. What it looked like, big shovel, putting things into a big truck with drill and blast. The business process has changed very little. Now, when I gave this talk, a version of this talk, actually at a conference in Germany in 2018, and I pulled this slide right up front to show them, to actually say, here's a case study of the mining industry doing something really interesting. And this was a talk I had given literally 10 years earlier. So I'm giving this talk in 2018. I said, here's a slide from a talk I saw in 2008. And I thought the German coal industry was well ahead of almost anybody else, where they were not only doing the teleoperation type automation, but they had PCs and handhelds with underground Wi-Fi working. They had a remote op center. They were doing Wi-Fi enabled barcode scanning of parts and materials going underground. They were doing a video camera trial and looking at doing augmented reality in 2008.
Wow.
Unfortunately, and it was partly driven by the fact that the German underground coal industry, of course, you may recall that the Ruhr Valley is what really drove the German economy, particularly through the war, to the level that they even cracked the problem of creating oil from coal. But they had these great coal mines in the Ruhr Valley. And in 2018, they only had one of them still operating, and it was due for closure, and it did close in 2018. And so it was the pressure of trying to make these operations safer and more economic, because running a coal mine in a nation like Germany with the labour costs, etc., and their niche sort of, they're not the bigger, in Australia we've actually got better coal deposits and bigger mines. So for them to be competitive, they really just ramped up their technology, and I think a lot of it was just going to be lost because they're closing, they were closing that coal industry. Maybe they could start reopening some of those mines given the Ukrainian situation, but anyhow, so that was really an example of a comparison. An industry that was not really innovating, to me, that says there's no excuse for that. You could innovate, here is, rag coal, absolutely with a key partner. They had a technology, a German technology company, sort of similar to CSC, actually partnering in doing a lot of this stuff, and it was amazing the things that they were doing. So, open innovation, what is it? So Henry Chesbrough coined that term for the use of purposive inflows and outflows of knowledge to accelerate internal innovation and expand markets for external use of innovation. So he's the guy that really coined the term open innovation, and he's still considered the leading researcher. He's from Berkeley, I think, and they run every couple of years. There's a big conference that his group runs, and I attended it remotely in 2020, I think. It was pretty interesting, academic, but it's really, there's a network of people working on this open innovation topic. But I've got this graphic here as an example, and I've taken those that you may remember, Kai Kaya and Laurie Locklee started a company called Optimize to do social networks analysis as a means of where is the knowledge, and this is some diagrams for there. But before you're doing a lot of good network collaboration, you might have this, what your organisation might look like. But then by the use of innovation network champions, you can really connect all the silos across the organisation. And so traditional innovation is, the classic pipeline where you capture the idea, you do concept development, you do detail and validation, preparation and launch, and then you expand the market on it, which is roughly the research, development, commercialisation pathway. And typically you might start having academics involved in the ideas end of it. You might bring in your partners at the concept development. Then you might bring in your suppliers to help in more detail. Then you bring in the customers. And then you might let the competitors know what's going on once you've launched it. Definitely. But the open approach is, well, why don't we bring all that forward into the mix and get everybody doing it much more collaborative right from the get-go. And so if you then go back to that, dumb that process down to really idea generation, maturation of the idea, and then realization is when you are launching and expanding the market. It's another simple model of how this the stuff works. We worked on this model when I was in the Natural Resources Centre of Excellence at CSC. We worked up this as a formal process. We called the 4-quarter process. Being Melbourne-based group, then of course it has to be 4 quarters in any good footy match, and this is the way you did so you'd have some idea funnel to bring in ideas that you would qualify, and then you'd run through this process of putting the perspective out to market as quickly as possible into a point of view that you would literally start publishing stuff in the market, and then you'd look at incubating those insights. And then turning them, if they turned into something good, then you're into the service definition commercialisation process. So it's a different approach. There's another companies, that Claro Partners, they had a view of how they think the pipeline works and inspiration, ideation. So they make maximum use of this ideation that I'll talk about more. It's how you do this ideation, and then the investigation and adoption process. So open innovation, there are sort of different approaches. You can actually talk about different models of collaboration, because that's what it really amounts to, is how you're collaborating. And in a mining context, you really got miners and then providers. From a technology perspective, you're either a miner that's using the tech or you're a provider providing it, even if that provider is an R&D group within the mining company. But anyhow, typically the most simple form of collaboration is you're doing it yourself, or you're doing it with simple one-on-one linkages with specific research providers. And you'd all know that typically BHP and other companies would often work with universities, but one university for one project, sometimes 2 universities for one project, but very seldom. It was almost it was Jeremy Davies trying to call me from the UK. His ears must be bleeding when I'm talking about the Natural Resources Centre of Excellence. the way I screwed it up. I mean, the ears burning, but into the bleeding stage. Anyhow, the next way of looking at it is you can say, well, the collaborative one-to-many, one mining company working with many providers at once, or you might have many mining companies contributing to one research provider. Is simple collaboration, that sort of one-to-many or many-to-one. Then you go to many-to-many, and sort of a group like Amira that does research brokerage. That's where you get the role of a broker to say, okay, how do we get multiple mining companies contributing to a project that could involve multiple researchers? And that's when you really get into the difficult you've got cat herding on both sides, basically. Well, the fully open would be to turn that model into, yes, you might have a broker that's managing the process, but you're getting linkages happening everywhere in a much more network-centric manner. So you're really just increasing the network as you go into an open innovation approach. So another way of looking at open innovation, really, the earliest examples of open innovation is really just crowdsourcing. And there are different ways of bringing that crowd together. And so you'd probably be familiar with a lot of the online classic crowdfunding services where you just, GoFundMe type stuff to get your money, or there are investment brokerages that source investor funding to get multiple people investing something, or even a recruitment site that's a sort of an online open source of getting people and projects. Then you might look at online collaborative platforms that either just collaborative online innovation networks, coins, communities of practice, those sort of things that are all done online, undertaking projects and developing knowledge as those sort of platforms. And then you've got these ideation platforms where you're generating and shaping opportunities and solutions in an online manner, but in a very collaborative approach. So that's the online platforms. But then the other approach, other more traditional approaches actually, is doing it in workshops face-to-face. So you could do that through innovation consortia with major challenges where one-to-many or many-to-many type consortia getting together to solve something. And then these hackathons that are sometimes specific challenges done over short periods of time, but they're done in a workshop and not online. So if we just look at some of the online examples of technologies that enable this, this is just a small list there's hundreds of these goddamn platforms for either doing crowdfunding, Kickstarter, Indago, GoFundMe, investment brokerage. Australian Innovation Network was one example. I'm not even sure if that's still going, that one, but anyhow, recruitment, Mechanical Turk recruitment, collaborative online innovation networks, Jive.com, Status, Drupal, lots of them, Yammer, there's a whole, there's just hundreds. And innovation challenge technologies to support these sort of challenges. There's also a long list of those. So there's plenty of technologies, and even this was pre-pandemic, right? So the pandemic, if anything, has really ramped up this whole area where so much more is going online. Anyhow, just to give you some examples, and this is back from 2015 when I first put this together, and even now looking at it, pretty impressive. This flying robot someone was trying to get going in Kickstarter, and it was going to be a Wi-Fi and Bluetooth comms. It was going to cost you $520 to get one, but it had GPS, accelerometers, gyroscope, barometer, magnetometer, and all these things they were going to have. I'm sure they didn't achieve all those things, but it was going to be a very smart little UAV for doing all sorts of things. But that's the sort of thing you would get, and that was sort of better than any commercial UAV for these sort of things. We do have these off the shelf now, in effect, but because there's been so much UAV development. Take another example from that time, from an Indago example, was one that was proposing a self-charging GPS tracking device. Just have a little button thing that would literally use motion charging, like those watches that used to be self-winding watches. You'd use a mechanism like that to charge the thing, and it was actually going to do cell phone comms and GPS location to track items. And now I quickly looked up before how many pet tracking, you have to look up various sites to see which pet tracking device that you can get. There's lots of them on the market now, but back in 2015 that was a pretty novel. And again, an approach to, well, how did someone came up with the idea, put it up on a crowdfunding, give me the money and I'll make this. Investment brokering example, there was a good example there of a company that was basically, this is where your classic investment, you're putting it up for investment to say, okay, we want to have 900,000 to develop this. Who's willing to kick in at least 10 grand to get 0.2% equity? And then they bid up, and then companies already do it. And it does work. This particular system already had customers already being used by Chevron in their LNG project, and a government building audit facility. So they already had, they developed the device. They were just looking for money to take it to market. So ideations. Now, I don't know who's. Did anyone contribute to any of the CSC ideations? Michael, do you remember? Do you still do those in CSC or DXC?
No, a lot of that disappeared probably when probably after we took over UXC. UXC, we actually doubled in size, and a lot of that went sort of away. Unfortunately, just sort of died a death by stealth. Unfortunately.
Well, I think it was because it was the CEO was keen on this. I remember him doing who was the CEO before?
Would have been Nick Wilkinson or
no, I'm not talking about Australia. I'm talking about globally. These were
not Mike Lowry. All that stuff got cut
before him.
Would have been before him.
Yeah, that's right. Anyhow, but I remember at the day in those times the best example actually I saw at the time was the Cisco iPrize. It was actually written up in a Harvard Business Review article, and it was really impressive what they'd done. They'd put up a decent prize, 250 grand, with a challenge, and got a whole bunch of people pitching. They got 1,200 ideas submitted. They got 40 semi-finalists. They had 6 full-time Cisco people spending 3 months evaluating the entries and shaping the finalists. Part of this ideation is sometimes the merging of, people pitching different ideas and they're overlapping, and then you'd start suggesting, why don't you get together with that guy? Your idea plus his idea would make an even better idea. And you say you sort of have the evolution of the ideas as you go. And the idea is to come up with a subset of really good ideas. And then you get a final list based on the highest votes, most comments, and a Cisco evaluator ratings. And 70% of the final 40 were actually collaborated with other entries and combined forces like that. It was a really good, well written up, that HBR article really described it well, and I thought, shit, this is the way to do it. I mean, CSC did do it, but weren't 6 full-time people spending 3 months doing it. I mean, that's
no, they would never have invested that level of money.
Anyhow, it's still written up on the Bright idea as one of those technologies to enable this sort of thing. So it's one of their case studies. You can see it as well as on the Cisco site. Siemens were getting into this in 2015 and 16, and I think they're still been going. And they were early on getting it sort of often targeting, future, waste management, energy, food, ag, that sort of stuff. Prizes weren't as big, but still, not to be sneezed at. 50,000 euro first prize, and just coming up with good ideas. And anyhow, the interesting part of this is that the first time this is now, I was going to start adding stuff about open innovation and the role of open sourcing, because of course the IT industry has really led the crowdsourcing way with the open development of several computing platforms and software and operating systems, and Linux probably being the most famous success story. But it was really this guy who was running this Canadian gold company who went to a talk on crowdsourcing software, and he says, well, shit, why can't we do this for exploration? Why don't we put up because he had the problem of they were running out of gold. They had they'd been exploring in this area in Canada for years, for decades, and they had a shitload of data, and he thought, well, why don't we just put it to the market, and who can come up with the best idea to drill here, and against the best advice of his explorations, who were horrified with the idea, he said, listen, we've got, we control the exploration acreage. Who cares if competitors see this? And he really pushed it. He had a decent prize, 575 grand US in 2000. That was awarded in 2001. It was run in the year 2000. And it's famous in the crowdsourcing area. It is actually recognised as the first example of crowdsourcing the development of an idea based on something that wasn't software. This was, a real industrial process of finding a new ore body. And anyhow, so they went through it. It was a wonderful success. He got named in Fast Company's magazine debut list of the Fast 50 innovators. He got all sorts of awards for doing this, and it did lead to other Goldcorp challenges in more recent years. But after doing one, and the market perception of Goldcorp in 2005, when gold wasn't looking good in 2005, but Goldcorp in this particular survey looked really good. Well, this is 5 years after he's done this. Why? Well, he's found this was a success. He did indeed find the gold. The first prize, the other interesting part is the first prize was won by an Australian consortium of Fractal Graphics and Taylor Wall and Associates. And the guy running Fractal Graphics, Nick Archibald and Vic Wall, there's two guys, Taylor and Wall. But Vic Wall and just bumped into each other when they were pitching to a client, and they said, "Oh, have you seen this Goldcorp challenge?" And this guy was saying, "Yeah, we were thinking of entering because we've got this technology that'd be really good." He said, "Yeah, well, we were thinking of entering because we really understand gold exploration." So they joined forces. They had the technology and they had the know-how to use it, and they came up with the first prize. And in hindsight, when you talk to the guys, the 95 grand, because he really spread that money out to make it worthwhile for so many people to enter. But he said, well, it wasn't worth the money to win it, the effort they put into it, but it made them famous. They won this first ever challenge in mining to do something externally. And then Nick Archibald later sold his company to Rungi Mining. So whatever price he got for that probably was his real prize for this. So the odd thing to think about is, so this is the first industry outside software, or the ICT, not just software, but out of ICT, the first industry to do open innovation like this was the mining industry. And then they didn't do it for 15 years. That was like, what the hell happened? It's like, and then back in 2015, I'm giving this talk. Finally, it's starting up again. Integra Gold Rush was trying to repeat pretty much what Goldcorp were doing with a very similar scenario. They were giving a prize of $1 million, I think, Canadian dollars. I should have specified that, but anyhow, again, a successful project. And at the same time, about that period, there was also this Frank Arnott Award, which is where these bunch of aging geophysicists are really concerned that we're just not training geophysicists like we used to. And the industry needs geophysics more than ever because of the increasing depth of targets. We need to be doing good geophysics. And this guy, Frank Arnott, who was a De Beers and Rio Tinto geophysicist, but he was a pioneer in the idea of really integrating a lot of information together, not just interpreting one data set and another. How do you merge all this and how do you collaborate with geologists? And because he led that, they've made this award in his honour. It was very successful when it was launched. It took them a year to pretty much do it. They gave the awards. Took a while because they wanted to do it at a major conference to actually present the award. It was all done by a volunteer group. That's part of the reason why it took a long time. And then they ran it again. After they'd done it, they reluctantly ran it again because everyone says, you've got to do it again. So, this is a lot of work. So they did it again. And then they managed to sell it to this Canadian group that runs the PDAC conference. Loved, the presentation of these awards at PDAC was so popular. They said, well, we'll run this. Give it to us and we'll run it, which they've been running ever since. And so, I was really impressed with that one. Anyhow, if you want to look at some recent examples. Sorry?
In the previous slide, what did those red dots mean? Is that like an ore body of something, or?
In the world. I give up. Why do you think? I don't know.
I don't know.
I mean, I honestly don't know. It could be anything. It's from a geophysics point of view, it does look a bit odd. It's an interesting thing to point out. I can't even remember where I got this picture from, and whether this might have been actually one of the outputs from one of the groups that were interpreting it. So maybe it was their view of where, I wouldn't say it's the goal, but it might be targets. I mean, to me, that looks like some sort of a target map of where the best targets are.
Okay, Australia's, I guess that's why we're the country. It's full red.
Well, they ran different. They had data sets from all over the world, and I don't know where that one was from, but different types of geological terrains that they want to do, and it was really successful. And their objective is to train the next generation. You know, that's why it's done as a volunteer effort. They're always struggling for money. I noticed PDAC's not offering nearly as much as even the first one. They're offering, I know, 50 grand or something less. So they've probably been impacted by COVID, so they don't have as much money. Anyhow, so looking at some more recent examples to show it's really taken off. I mean, I could collect how many have been done in the years since. There's been lots. Every year people have been running these challenges now. It's like we weren't doing it. So the mining industry, if you like, could say, was the pioneer in the non-software application of this, and then did nothing for 15 years. And then rediscovered it, literally rediscovered it. Oh, this is a good idea, and then off it goes. And so it's I can't keep up with it now. And two of the more recent ones that are pretty interesting. One is Oz Minerals. Last year they launched these two, and so they've only recently been awarding. Just this year, I think they've been awarding. It takes them a while for these major challenges. So there was this ingenious extraction challenge for better copper recovery that Oz Minerals were doing it, looking at how to extract metals, key metals from copper concentrates, and come up with a better, lower carbon methods of doing this. They had 260 participations, 40 countries, 55 submissions, 10 finalists. And then from that, they selected 6 novel solutions that were actually worth giving a try, and they're funding trials of these 6 finalists. And Osmine, they basically agreed to do it on behalf. BHP was interested in doing that, and they went to Osmine and says, we'd like to do a challenge. We want to make it a multi-company challenge, so we can't run it. Can you run it for us? Osmine is the supplier industry association in Australia. So they took, and in fact, I think an ex-CSE guy is actually running it. Martin Collard is from Perth. In fact, I hired Martin Collard, so I know him quite well. I've been meaning to talk to him about how that's been going. But so they had these founding patrons of BHP, Rio and Vale, and then they got 18 other mining companies to join in. And it was all about to accelerate the commercialisation of solutions to deliver electricity to large battery electric off-road haul trucks, you know, the big trucks, 220 tonnes or more payload. And BHP had already had a project where they were calling what they call a trolley assist, which is basically, you know, putting, you know, how we have overhead power lines for trams. You know, the word for a tram in many countries is a trolley. We call them trams, but other people call them trolleys. But anyhow, so the truck would actually have a bit like a tram, that connector, that when it actually has to go out of the pit. The big problem for these large trucks is that whether you're an underground or a surface operation, the truck's got to climb out of the pit, you know, a long way. And so it's the potential energy of moving 220 tonnes up a hill. You know, you just don't have enough battery power to do it. So the idea was the truck would then hook onto a tram line to go up the hill. That was what BHP was trialling, and it wasn't sort of working well enough for them. They're having all sorts of issues, and they thought, oh shit. And then they thought, well, why don't we just put this up to a challenge to see if people can come up with other ideas, or either ideas to get this thing working or other similar things. The main objective is how can we get a battery-operated truck to actually haul the ore. And they got 8 winning solution concepts from lots of countries around the world. And only just this year have been announcing they've got these concepts, and I think they're moving ahead with several of them. So it's definitely an idea whose time has come. The other thing is looking at the face-to-face workshops. There are ways of doing open innovation approaches to that. And an example of that was the Anglo-Gold Ashanti Technology Innovation Consortium that CSE was a party to. and that Dennis Franklin and I attended that on behalf of CSC. But interestingly enough, in the days, you know, how hard it was, probably still is, to get overseas travel from CSC. We managed to get AGA accepted us as being a research organisation because it was the CSC Centre of Excellence doing this, not CSC, and therefore they paid for the airfares, which they were paying for other universities and stuff. So we got business class airfares and accommodation paid for. So we were able to do it. It was just multiple workshops over several years to actually solve this problem of how do you mine deep underground. You know, AngloGold Ashanti in a mine called Mponeng is already the deepest mine in the world, down at 5 kilometres. At 5 kilometres, the ambient temperature of the rock is like 80 degrees centigrade. And so the biggest cost for the whole operation is running a refrigerated air conditioning system where they have giant ice-making slushy machines that then that convey down the shaft and into a refrigeration lake at the bottom, and literally running refrigerated air conditioning to cool down the rock so that people can work in it. Well, as you're getting deeper, that's becoming not viable anymore, and of course lots of other challenges as the deeper you go. So they were trying to come up with, well, how do we solve this? So they were pulling together a consortium involving 30 companies from around the world, and they were sort of picking specialist companies, suppliers. Like GE was there for their electrical capability, ABB was there for their automation, DuPont was there for their chemical experience, 3M for materials, and CSE got a Guernsey for IT, and the only IT player. That was the advantage for us. It was a great thing to be involved in, where you're the only IT player in the game. And the idea was to come up with this whole new mining paradigm and then pilot technologies to come up with it, then run some pilot projects. And they did get it down to that level, came up with an entirely new mining method that they were then going to run a trial. I think the problem has been AngloGold Ashanti has sort of run out of puff as a company. The very reason they were doing this innovation is that they were in a declining production. They had all these deep mines in South Africa that were running out of ore, in effect, except by going deeper. I think the things caught up with them. So I'm not sure where it ended up with the whole thing, but of course, Dennis and I carried on even after we left CSC. We still carried on as being members. In fact, we still attended on behalf of CSC because no one in CSC was going to pick it up, so we kept doing it for another year.
Exactly. I'm not surprised.
That's right. And not even providing time for someone to go and spend. Even the people in South Africa, there was a guy in South Africa that was joining in when he could, but even for him to be given the time to do it was like getting blood out of a stone. So we carried on with it for a bit longer, and then lost contact with it. But I thought as a process it worked really, really well. Another similar example, but a much shorter term thing. This was like over several years they were running these workshops from 2010 to 2013, to get it to a proof of concept stage. These hackathons are things that, what can you do in a weekend? So they made them 54-hour events. You might have seen them. There's a lot of IT-based hackathons, government hacks and other things to come up with quick IT solutions. But this was targeted at mining, and this company was set up, Unearth, specifically to go after these hackathons, and they'd done 25 events when I last compiled this diagram in 2018. I think it sort of really trailed off because these guys got into running these innovation challenges, like one of the ones before, the one that Oz Minerals hires these guys to actually do their online challenge. I think they found those online challenges are a much better money spinner for them than running these hackathons. But anyhow, it's like, what can you do really quickly by having teams come in? And they were just running them every year, and eventually starting in Perth, but eventually spreading all over Australia and all over the world. So it was successful as an approach for a while. And here's an example of the very first one that they ran. Is Rio Tinto put up a challenge. They want to prevent large boulders from blocking crushers. What can you do? And the idea was, can we come up with a way of determining, does a truck have a large boulder in it? And so he's doing the hackathon where they've pouring some sand and probably with a big rock in it into a Tonka truck sitting on a ball, and they put an iPhone or something with the accelerometer to collect data and come up with the way that they would actually solve the problem. And they won the prize that year, and they got a trial engagement with Rio Tinto and maybe one other miner. But the prize was piffling, $4,000. But the recognition was what they were doing it for. I visited these guys, Newton Labs, in 2018 after I presented on this in Germany. On my way back, I came back through Perth, and I thought, I'll look up this guy to see how he's gone. And I was a bit disappointed, but not surprised that he was really struggling to get his solution to market. And it's one of those things that's like, I don't know why he would even bother. It's like one of those things that if you're a little niche provider, a little startup, and it's like, well, let's compete against the likes of Caterpillar in coming up with a new idea. I mean, Caterpillar would take one look at that idea and say, okay, go to your R&D people. Can we use our existing accelerometers to do this? Oh, yeah, we can, they could sort it out in a weekend if they wanted to. But I can tell you the ability to go and put any device on a Caterpillar truck, you go and good luck with that, right?
Yeah.
Without Caterpillar saying you put that thing on our truck and you're going to void your warranty. And so I always thought there's something wrong about this point where you're getting all these young people that come up with these bright ideas with the view that you're going to create a great business. I just couldn't see how these things were going to work. Ideas just hatched in a weekend and then taken to market in an industry like mining. So I think they have somewhat petered out. I was always a bit suspicious of them. I only attended one of these things and found that most of the ideas that were being presented for the challenges, I could think of, there's already solutions on the market. It's just that neither the judges nor the people on the challenge happen to know what's already on the market. However,
isn't that the definition of a systems integrator?
Well, yes. Well, and coming from a systems integrator, I knew just how hard that job is, and trying to sell a new idea into a BHP or a Rio is like pulling teeth.
Yeah,
right?
it is.
It's just incredibly, incredibly difficult. And in a world that lacks interoperability standards for this sort of thing, and the dominance of vendors like Caterpillar. If you remember a previous talk I gave where I'm showing how Caterpillar is just absolutely dominating.
Yeah, I remember that was a good talk.
Yeah. And they're just, and they've just come in and they've bought the market. They've got Rio Tinto, latest mine is full of Caterpillar gear. They've got BHP, told BHP, oh, if you want the discount we're giving to Rio Tinto, well, guess what? You've got to cancel that innovation project you've got on OEM independent interoperability and automation. And so BHP cancelled it just to get the discount. And also they wanted the autonomous trucks. Caterpillar is, makes more autonomous trucks, big trucks, than any other vendor. The next is Komatsu, but Caterpillar's got twice the market of Komatsu, and Komatsu's got twice the market of the next player. So you sort of got an oligopoly happening there, and it's very hard to bring any solutions in around that. Anyhow, so let's look at can we combine these approaches of both the online and the face-to-face type things? And the best at doing this are the DARPA people. DARPA, Defence, who knows DARPA? Defence, some Applied Research, I can't remember what it stands for, but it was a group that was formed actually soon after the Second World War to actually improve innovation in defence and how to engage with the supplier marketplace in doing that innovation. Rather than the traditional way of saying, yeah, we need a new fighter jet, you go to Lockheed Martin or someone and say, well, give us this new fighter jet, and it costs a fortune and doesn't do what you really wanted. And it certainly is not the way to get breakthrough. And just to start with the bottom first, the most successful DARPA challenges have been these robotics ones, where they started the grand challenges for autonomous vehicles in 2004, ran them for many, many years, and the more recent one they called the DARPA Robotics Challenge in 2012 to 15. And then this was the latest one in that genre, robotics, but they wanted a subterranean version of the robotics challenge. And it was run from where was it, 2018 to 2021, and they had the who's who of what you call field robotics. The who's who of field robotics were involved in it. People coming together as consortiums, usually multiple universities and multiple research groups, suppliers. In this case, there was a CSIRO-led Data 61 with Georgia Tech and this company Emisant, which was also a spin-out from CSIRO, were coming together to do that challenge. And you look at that, there's the team in the cave. This challenge, it's just unbelievable how this challenge went. They literally set up, first you had to pass a tunnel challenge, just map out a tunnel, find lost objects in the tunnel, a tunnel system, not a tunnel system. Then you had to do an urban environment, basically underground car park type environment, to map that out and find lost items. And then they had a cave one. They had to cancel the cave one because of COVID, but then they just rolled it into the finals one. And the final, you had to do all three. They had this incredible location where, I can't remember what the facility was there, but it was a big facility that had been built next to a cave system, and you had to go and map everything. And the CSIRO team that sort of was, it was getting shortlisted because it was doing pretty well in the first ones, but they creamed the final event, and particularly because they were so good at the cave part of it, more so than the others. The others, I mean, the CSIRO one, it's not a bit hard to see there, but down there they've actually got they've got lots of different ground robots, but one of the big ones actually had this hover map UAV sitting on the ground robot. So the ground robot would go into the cave, and then the UAV would take off and map the environment. All of this had to be done autonomously. It's remotely not controlled, but you have oversight, but everything had to be autonomous. And you were autonomously mapping the system, finding these known objects like a hammer here or a helmet there, and reporting it back. And you had this point system and it was literally a draw for the 8 finalists, and the CSIRO one lost on a countback. But if you actually look at what they did, they did a much better job than the winner at actually mapping the tunnel. The winner actually just found it, got lucky in how quickly it found the last object. The last object it found was faster than what the last object that the CSIRO one found. But the CSIRO map, the judges said, well, the CSIRO map was a lot better than theirs, but here are the rules. These are the rules of the rules. Here's how we solve a tie. And so instead of getting $2 million US, they won $1 million US for coming second. But it's the only Australian finalist in any of these DARPA events, right? So these DARPA events, if you think of the world challenge in robotics, to even have an Australian finalist is amazing, and actually to come so close to winning, more amazing again. And it's just amazing. Now, the reason I know a bit about this is this picture here showing the hover map. This is a UAV with a LiDAR on the bottom of it, doing LiDAR mapping. Now, I ran an event in 2014, this mining event we ran. We had a pitch fest where we had 13 researchers and SMEs pitching new ideas into mining. And these guys, it was the first time they'd ever pitched it. The guy who runs the company, when I run into him, he's very thankful. He said, yeah, you guys were the first, you Pearcey guys. That was the first time he ever had to do a 3-minute elevator pitch, and of course he's done many since, because he's done a whole bunch of things. He's got funding, several rounds of funding. The whole thing's taken to market, and now they were part of this DARPA challenge. I'm sure they're doing really well. So the interesting thing, I couldn't help but pull out this quote that they use in the DARPA: the relationship between warfare and terrain demands the faculty of quickly and accurately grasping the topography of any area. And Clausewitz, the Prussian, famous Prussian strategist, wrote a book on war. Unfortunately, died in 1831. His wife posthumously published the book he'd been working on, and it's a famous book in war strategy circles. And in fact, he had a plan. For those that know, he had a plan on how the Germans could win a war in Europe. And they kept saying World War One was trying to follow his plan, but it wasn't. Hitler really followed his plan a lot better than they did in the First World War. But anyhow, but you can see why the defence industry is interested in this thing. They want to map tunnels to chase terrorists and others, but in the process, they're really providing a real push into the whole marketplace around robotics, field robotics, and so the interesting, just from an Australia perspective, one of the things I noticed Anthony Albanese announced in the lead up to the election, when someone was asking him about the whole AUKUS stuff, he actually made a point that one of the Labor policies is to change the way Australia does its defence innovation and do it much more along the lines of DARPA than what we've been doing. And that's about the only detail I know of it. But you know, it's like, yep, well, absolutely. So to me, DARPA really is the essence of, that is the proper way of doing it. I mean, that same competition, they ran in parallel. You could join and do the mapping in a virtual environment. So they literally had artificial tunnels and car parks and caves in a model, and you could run your software. I don't know how they did that. They must have had little robots that you could run, and anyhow, so that they had an online software challenge, that they also had I think $1.5 million in prizes. So I think the total prize pool was about 5 million. And so a lot of people were entering the virtual only one to try and win it. And then another group were doing the actual challenge, physical challenge, where you got to put the robots on the ground and do the mapping. Yeah, it was just amazing. Just to see the who's who of the world's academic research organisations that go after this. That's the thing that DARPA's got, because it's got so famous, that it almost doesn't matter what money they provide. People just want to win it for the fame in your marketplace.
It's a big deal.
Yeah, it's a big deal. And so I'm going to follow these hovermap guys to say, if they really, you know, there's quite a few other people trying to do what they do with LiDARs on the UAV and other ways of 3D mapping from a UAV. But I reckon these guys are going to get a real push in the marketplace simply because they know where the UAV in this challenge.
Isn't this what the geologists and the archaeologists have been doing for years with LiDAR 3D mapping?
Yeah. The thing about LiDAR mapping, if you think about for archaeology, is that, you know, if you're flying over a canopy and you're getting all these LiDAR reflections, of course, some of those reflections are hitting off the ground.
Yeah.
And so you can actually map so unlike aerial photography, you can strip away all the reflections that are coming off the foliage. And so you get the items, and you actually do get a map of what the ground does look like below the foliage. And I think that's been, if some of the work that's been done in the Amazon, all these civilizations have realised that we're growing up in the Amazon, unbeknownst to us, is now finding them through this LiDAR mapping.
Well, that's not the only one. It's actually going into a building and mapping the, you know, say the pyramids, for example.
Yeah. Well, most of that, people have been doing it with lots of cheaper systems, but it's always been remotely operated LiDARs, you know, a pilot piloting it through. To do it as a fully autonomous system. And these systems,
another matter, that's true.
The other thing too is that all these systems were talking to each other. It had to be fully autonomous. It was building a map and the different robots sharing the map amongst themselves.
Yeah, well, that's
what
new.
They're seeing.
That's new as well, yes.
Yeah. So it's definitely a grand challenge. And we will see the fruits of it. Anyhow, so what's next? It's really how to build collaborative networks across industries and across all types of organisations involved in the research. And we're trying to get this Pearcey Institute going on this pizza model where you're bringing basically people from, and I really need to update it from a quadro stagione to, it needs to be a 5-sector one, because a lot of people are saying, well, you've got to have the social, the society, you know, you've got a lot of citizen science and other things that come into it with the general public. So you need another one in there. But you've got all these different groups that are doing research, and a lot of people that show this have it a 4 model with society being it. But I like to split business into business and technology, because most of the innovation in the ICT space is between a person that's got the problem, an industry that's got the problem, a customer that's got the problem, and a supplier that can supply the solution. So most of it's happening, you know, without government or research organisation involved. So it's been one of my mantras is, well, how do you get all of these groups working in an optimum collaborative fashion?
Yeah.
And one of the things is, what's the best target? Because the difficulties I was having with interoperability was making me frustrated over the miners are just not willing to collaborate on almost anything. And so I was seeing in 2015, I thought, well, we really got to go after areas that satisfy these three things. It's got to be an area where competitive pressure is lower, right? So it's not part of the core value chain. So this is our core business. We're not going to collaborate with our competitors around this. So you'd take peripheral areas like the innovation process itself, the maintenance activity or sustainability activities are things that fit. Your compression pressure is lower. In fact, there's a good reason for everyone doing this in a common way. And interoperability is less of an issue because the solutions in this space aren't as complex as these. And there's a simpler stakeholder landscape. You know, there's always someone you can get to in any company. Who's the person? There's an R&D manager that's in charge of that. There's someone, an asset manager or something that's in charge of that at a corporate level. And then there's a sustainability person at the top of the tree that you can get at there. And so that's what I thought then. However, with these recent examples that are happening, when I look at them, I'm thinking, well, what's the driver behind them? It's all the net zero CO2 stuff driving it in more recent times. It's like the miners want to do this quickly. They want to get to net zero. And there's two things happening there. One is they want to drive CO2 emissions down in their current operations, so they're good corporate citizens to say we're going to meet whatever 2030 goals or whatever they're going to commit to. They're going to try and cut down their own CO2 emissions, which frankly is irrelevant. You know, from a mining industry, the amount of emissions that the mining industry itself makes is not as significant as other areas, but nevertheless they all want to do it, right? Like, for example, who cares from a planetary point of view if the coal miners improve their efficiency by 30%, right? 30% less CO2 in the mining of coal. Yeah. And then you burn the coal and have so much CO2 from that, it just sort of makes a mockery of it. But anyhow, so nevertheless, they're all got corporate objectives, and so they're putting money into how do we reduce our own emissions, and hence that trucking challenge sort of fits into that one. Expected rise in demand for clank minerals. Clank, the new term for critical minerals, and it stands for copper, lithium, aluminium, nickel, and cobalt. Are the core metals that the future technology, whether it's solar cells or wind energy or anything you like, we're going to need a lot.
Batteries are the big one.
So lithium and nickel into batteries, but copper and aluminium, you know, the infrastructure you've got to build is, there's a lot more aluminium that goes into a wind turbine than bloody, you know.
Well, there's a lot more copper in a transmission line than anything else.
And there's a lot of copper in the transmission lines and stuff. So you'll hear more about this clank minerals. Is the expected rise. I mean, we can barely meet the demand for these metals in the current demand. But if the world wants to go to net zero by 2050, we just don't have enough. There's just not enough deposits in the world. We've got to find more and we've got to develop them quickly. And the miners are seeing that as an opportunity, and they want to speed up everything as well as do it in a low CO2 method. And by the way, the governments and community stakeholders are demanding commitment from mining companies that they're serious about this, and so they'll do it just, you know, they'll do R&D for that reason alone, even if they don't, you know. So I think those three things together are going to drive it, and that means the sweet spots are coming in other areas, like in the core exploring. We need to find more deposits, have better ways of mining and processing it. Is where a lot of the effort is.
Hey, Colin, just a quick question. Isn't cadmium supposed to be an important mineral for batteries, or is that just old technology?
Sorry,
cadmium, C-A-D-I-U-M.
Cadmium.
Cadmium.
Cadmium. It's for the old nickel cadmium batteries, but you know, lithium's really. It's hard to beat lithium as power, because lithium is what the third lightest. Hydrogen, helium, lithium. So
There's been
not quite that, but
the lightest. So that's the problem with a battery.
There's been a fair bit of chatter about aluminium and sulfur.
There is
and sulfur.
Yes.
There is so much battery research happening in the world.
Yeah,
It's
huge.
It's just incredible. It's just absolutely incredible. And if you expand batteries to electrical storage, so you're then into pumped hydro, into those gravity systems, there's just, and other chemical methods of storing it. I mean, a lot of the push for hydrogen, if you think of, I personally think it's going to be, ammonium's going to be the transport mechanism for hydrogen, because it's easy to transport ammonium at
absolutely
at atmospheric pressures and temperatures. But hydrogen, to get hydrogen down to a liquid form is just ridiculous amounts of compression, and then it so I reckon the ammonium route is going to be part of that. So that's like a chemical storage solution to store hydrogen in a way that can be then transported and then re-liberated into hydrogen when you need it. But it's just incredible the amount of developments of it. But from a mining perspective, and just as an aside, here's my prediction. I think Twiggy Forrest is working on this one. A real opportunity in Australia is that to come up with green steel, green iron and green aluminium, right? Because the world still needs so much. Is built on steel and aluminium. And both of them are incredibly energy-intensive processes to create those, to smelt those.
Certainly are. Yeah.
So can you go with a much more renewable approach? And so if you were, for example, to build, those that remember the HBI project or the Budari Iron project in the Pilbara, where BHP were trying to create iron ingots, and the idea is that would feed electric arc furnaces with iron ingots. The problem with electric arc furnaces is that at the moment they're mostly fed by scrap metal, and therefore the quality of the steel you get is just got too many impurities. You can't use it for high quality steel. However, if you had good quality input like pure iron ingots, then electric arc furnaces would produce great steel. So it seems to me that the obvious thing for steel is, and for Australia, is that we create green iron using renewable power to drive a HBI type process in the Pilbara. We export green iron ingots to places where they want to convert it to steel, again with electric arc furnaces driven by renewable energy source. And you just dodge the coking coal process altogether.
Yeah.
Aluminium's a little bit difficult. The electrical winning process that's used is hard to beat. Same with copper. But anyhow, people are working on that challenge that Oz Minerals is doing, is trying to come up with all sorts of other leaching methods that you could use to avoid. I don't think it avoids the electrowinning part of the process, but it avoids, the other part where you grind the thing to dust and dissolve it in acid, and anyhow, it's then run flotation. Yeah, that the whole process of producing copper is an incredible industrial process that has to be done on site pretty much, because the cost of moving concentrate is expensive compared to moving copper. That's why they do the electrowinning on site where they can, if they've got the electricity, do the electrowinning on site. And then aluminium, some people call aluminium solid electricity, because there's more electricity that goes into making aluminium than anything else. So I think that's going to be the next driver for open innovation, and it's partly because people, they want the solutions quickly. We don't have time for this anymore, and so everyone's, how can we do it as fast as possible? So embrace these open innovation methods of actually coming up with ideas and implementing them. So that was really my last
Colin?
slide. Yep.
Just a quick question. I was just going to go over something you mentioned. So the day we get green iron or green steel, does that mean coking coal will not be ever used again?
Well, it's going to take us a long time to wean off coal. It is a process that's going to take till 2050 to wean ourselves off.
Yeah, just the investment to get the quantities up.
It's just the amount of base load that's already produced by, and you can see now that Germany's ruining the fact that they were busy closing coal-fired power stations and uranium power stations in recent years. And their solution to that was to become dependent on Russia for those gas pipelines. And now they realise the error of that strategy. And
wasn't too good, was it, in tonight's news? Did the Russians blow their own pipes up?
Well, is that, but is that a bit like conspiracy or incompetence? You know, it's like, you know, do you really trust, you know, I mean, the Russians do really know how to build stuff. You know, they got the first man into orbit, and they could well have beaten the Americans to the moon in another, you know, alternate reality. But you know, under Putin, you know, Russia's not what they used to be, even under the communists.
Yeah.
And you know, this whole, you know, it's the problem of the oligarchies, right? You know, that it's a corrupt system, and so that just leads to all sorts of, you know, corruption in the process, and even under the communists. Say, if you go back to when Chernobyl, if you look at the lessons of Chernobyl, it wasn't so much that, you know, it was what they did after the accident that was exacerbated because of their political system, that no one, you know, they didn't want to actually admit what had happened. In fact, the people at Chernobyl didn't want to admit to Moscow what was going on and trying to cover it up and trying to fix it themselves. And then when Moscow found out what was really going on, because they sent in their review team, then it was like, well, how do we not tell the world how bad this is while they try and fix it? It just illustrates how you can corrupt what should be a technical problem that you're trying to solve.
It's also Russia's a kleptocracy. You know, the first consideration is, what can I, as a officer of the crown or whatever it is, you know, can make out of this? So if you're a general in the army, the idea is, how much can I sell the supplies that my unit's been given?
Well, I think for me, a lot of it comes down to actually just good governance, right? Governance in the original sense of the term. You know, who's overseeing someone doing something and making sure? And part of the problem in the communists, we had a bad name for having the commissars that were providing the governance on being a good communist. More important than anything else was the problem there. But who checks if you've got these autocrat or the kleptocrats, you call them?
Kleptocrats, absolutely.
That are making money of it unchecked, right? And Putin is getting a slice out of all of this money. You know, some people think he could be the richest man in the world.
Yes,
because he's getting a slice out of everyone that's got their hands in the till. So where's the incentive for him to put good governance to make sure they're not, you know?
Well, he hasn't, because if he loses power, then he's going to go to jail.
Well, no, it's worse than that. He knows,
and he knows that.
He loses power, he's a dead man. He's going to be.
Well, that's assuming that he lasts long enough to get into jail. It'll be tipped out. What you know, a lot of the oligarchs that are mysteriously dying of various causes. It'll happen to him.
I worked for this company once, and they had an order for Russia, and they ordered 12 of everything, but you had to put 12 plus 1. So it was actually 13 of everything. And I said, oh, who's the 13th for? And you couldn't charge them. They said, oh, that's for the Russian mafia.
The
baker's dozen.
Baker's dozen. You know, 13, and I said, oh, okay. And because then it was screwing up all the inventory, and you know, you had to allocate it to someone to bill somebody, and the boss said, well, just bill me. And I'm okay. Crazy.
Well, I think so who knows what's going to happen. And, you know, just from back to the innovation topic, I mean, you know, the Russian innovation system is broken. You know, great engineers, great scientists, but they just haven't got a system that they can shine. And America's getting like that too, right? I mean, honestly, if you know, it's not, you know, this winner takes all mentality of you know, the richest just keep getting richer, it's really going to stifle innovation, because they're not going to allow others to come up. You know, we'll be back to that. You know, we know Microsoft used to be famous for, you know, taking over companies just to kill the competition. That'll just keep happening.
Yeah. Cole, thank you very much for yet another fascinating presentation.